Hi, Integrated Math 1. Welcome to lesson 2.4.3b. We're on day 2. So we've been doing area and perimeter of polygons on the coordinate plane, and we learned some cool tricks, right? That if you cut things up into rectangles and triangles, you can find the area. And of course, we can always use distance formula to find the weird sides to help us out with perimeter and various other things. So today, we're going to determine the perimeter and area of trapezoids and hexagons on a coordinate plane. And we're going to do that by treating them as composite figures. Ooh. So you know this trick. You've determined the perimeter and area of rectangles and triangles. And so we can use those shapes to determine the area of other polygons on the coordinate plane. We can chop our shape up into rectangles and triangles, and it makes it so much easier to figure things out. So distance formula will help to find weird sides for perimeter. Chopping things up into rectangles and triangles will make it easier for us to find the area. So with this in mind, we're on page M2-292. We're going to work on some perimeter and area of a trapezoid. So Ada's bedroom is on the top floor of her house. In her room, the roof slants downward. So because it's on the top, the roof kind of slants down, and that happens. So it creates two congruent trapezoid-shaped walls. So because that roof is coming down, she has one on the left, one on the right. She's got two trapezoid-shaped walls. One of the walls in her room is represented on the coordinate plane by the quadrilateral A, B, C, D. Golly, these lights. I know. And each interval on the plane represents 1 foot. So again, that feels important. Units. I'm gonna just be like, underline that. Like, that's a foot. It's important. It matters. So please remember that this quadrilateral is just representing one of the walls, that we actually have two of these trapezoid-shaped walls. So you might want to underline that as well, just so you remember. And Ada and Marco are going to paint the two walls. And they want to place a strip of painter's tape along each edge of the wall so the paint does not touch any other wall, the ceiling, the floor, right? You put painter's tape around it so you don't get paint all everywhere, and it makes for nice, lovely edges. So question number 1, what is the length of painter's tape to the nearest whole foot that Ada and Marco need to be able to cover the edges of both walls? That's a good question. Hit pause to work this out. Hit play when you're ready to check your work. Now, because they're just doing paint around the edges of the walls, this definitely sounds like a perimeter problem, right? We're just doing around the outside. We're not taping over the whole wall. We're just taping around the outside. So this is a perimeter problem. Now, some of these sides are easy. Some of these aren't. I'm just going to tackle the hard one right off the bat. Let's find side AB. It's a little beastie guy, and I'm going to have to use some distance formula, but that's okay. So distance formula, I need some coordinates. It looks like A is at -5, -1, and it looks like B is at 6, 3. I feel like that's a good height. So let's do some distance formula. We'll subtract our x's. -5 minus 6, -1 minus 3. -5 minus 6 is -11. -1 minus 3 is -4. If we square them, we get 121 and 16. Together, that's 137. And the square root of that is about 11.70-ish, roughly. And we'll worry about rounding in a little bit. Of course, the other sides are nice. You can just count them, right? AD, it looks like 1, 2, 3, 4 units for AD. It looks like DC, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units for DC. And then for BC, again, I can just count 1, 2, 3, 4, 5, 6, 7, 8 units for BC. And for perimeter, we're just going to add them together. I get 34.70. Now, 2 things. There are 2 walls. There are 2 walls. So make sure you double it. We got to double that because there's 2 walls. So we actually need about 69.41-ish feet of tape. And let's answer the question, how much tape do they need to the nearest whole foot? We better round that up because I don't want to end up with too little tape. I realize if I round it properly, it'd be 69, but then I wouldn't have enough tape. So I'm going to round that up. And I'm going to say that Ada and Marco need about 70 feet of painter's tape. Did you catch the trick about 2 walls and doubling it? Did you catch that? I hope you caught that. I'd like to think that you did. Now, they're ready to paint. So they've got their painter's tape. They've edged the walls. Yay, they are ready to paint. 1 gallon of paint covers approximately 400 square feet. And Ada estimates that she has about 1/4 of a gallon of paint remaining of the color she wants to use. Does she have enough paint for both walls? Crunch some numbers, do some math, hit pause, work that out, and then hit play when you're ready to check your work. So we're painting the walls. This is an area problem, right? We're dealing with area. So first of all, I'm going to figure out the area that I'm dealing with before I wonder whether or not I have enough paint. So I'm going to go ahead and cut this into a triangle and a rectangle. We know that's easy to use. I already know this side is 11. I already know that that side is 4. We did that earlier. That means for the triangle, I have a base of 11 and 1, 2, 3, 4. It looks like my height on that triangle is also 4. So great. 1/2 base times height, 1/2 11 times 4. That gives me 22. For the rectangle, just base times height, so 11 times 4, which is 44. So it looks like I've got, for the wall, it's going to be 66 square feet. 2 walls. So I need to double this. And it looks like we've got 132 square feet of wall we need covered. Now, let's come back to the paint issue. If she had a whole gallon of paint, she had the whole gallon of paint, it'd be 400 square feet. But she's only got 1/4 left. So if I cut 400, I divide that by 4. Oh, she only has enough paint for 100 square feet. She has enough paint for 1 wall, but not for both of them, does she? So Ada does not have enough paint for both walls. She's going to have to go buy more. Just saying. Nice work, guys. Now I'm going to mess with you. Emma and Kevin are designing a gazebo for the local park. The polygon shown on the coordinate plane represents the base of the gazebo. Each interval on the coordinate plane represents 2 feet. Now they were nice enough to give us the coordinates here. Do watch out, there is a typo in your book. There's a typo in your book. I believe this is supposed to be 0, -17. Where is that -18? -18, sorry. That should be 0, -18. It is 2, 4. There is a mistake here. I promise you this problem will work out better if you make that -17. I know it looks like -18. I get that. That's what they wrote. But I promise this problem will be better if you make that a -17. Method to Miss Scott's madness. Trust me. Go ahead. Let's take a look here. The base of the gazebo needs to be built with lengths of lumber around the outside to support the floorboards, right? Because this is the base of the gazebo. So they need to put lumber around the outside that they're going to put the floorboards on. So we need to know how much lumber. What is the length of lumber needed to support the outside of the base? Hit pause to work this out. Hit play when you're ready to check your work. So I was like, oh, this is a perimeter problem. Yes, it is. If I need lumbered around the outside to support my floorboards. So I went distance formula crazy. So to find AB, subtract my x's, subtract my y's, square them, add them, do the square root. And I actually got a nice number. I actually got a 17. Wow, that was convenient. I did distance formula again for AF. So subtract my x's, subtract my y's. Actually BC, that was 17. I could just count that. CD, again, subtract my x's, subtract my y's, square them, add them, square root. DE, subtract my x's, subtract my y's, add them, square root. 17. Oh, are you seeing a pattern? You could count this guy, FE, 17, and you can distance formula one more time for AF. Subtract my x's, subtract my y's, square them, add them, square root. So it turns out that all of the sides are 17. Well, that's nice, like, right? By the way, that's also why Miss Scott told you to make that a negative 17. I'm just saying, it makes the problem easier. Okay. So all of these are 17. Now, I could do 17 plus 17 plus 17 plus 17 plus 17 plus 17, but I'm lazy. So I did 6 times 17 instead. And that says perimeter. Oh, that should say perimeter, not area. Wow, typos, Miss Scott, typos. So perimeter is 102. So it looks like we're going to need 102 feet of lumber to build the outside of the base of the gazebo, just to make sure we can have something to lay our floorboards on. But of course, now we need to lay down floorboards. So how many square feet of floorboards are needed for the base of the gazebo? Make sure you show your work. May even need to give it a little description of what you did. Hit pause. How many square feet of floorboards do you need? Hit play when you're ready to check your work. So I chopped it up. I cut off the top to make a triangle, right? I totally cut off the top to make a triangle because then I was like, I could count it and I was like 1, 2, 3, 4. Oh, it's counting by twos. It's counting by twos. So 2, 4, 6, 8. So yeah, 2. I can do this, even though I'm in the dark. I'm not going to be in the dark. I refuse to be in the dark. Come on, turn on, turn on. Got it. All right, so 2, 4, 6, 8, 10, 12, 14, and one more is 15. Oh, actually, I can see 15 and 15. Oh, the length of that is 30. And I can see that the height of my triangle, 2, 4, 6, 8, is 8. And I did it again on the bottom. I cut off the bottom triangle, and I was like, whoa, well, the length of that is also 30, and the height of that is also 8. So convenient. So, we already know that this height is 17. We already found that side earlier. I think we have everything we need. So for the top triangle, 1/2 base times height. 1/2 30 times 8 gives me 120. For the rectangle in the middle, it's just base times height. 30 times 17, which gives me 510. And then for my bottom triangle, which actually matched my top triangle, 1/2 base times height. So 1/2 30 times 8, which is 120. So if I add these all together, the total area of the hexagon is 750. So this means a total of 750 square feet of floorboards are needed for the base of the gazebo. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please feel free to email me. And I'll see you guys later. Talk to you soon. Bye.